Hi, how's it going? You may hear a bit of fuss made about basically making our code cache friendly or cache adjacent. How does that work? Well, here's a quick little demonstration. I was playing around with this QuickCG package that I was porting before and kind of got it working. Still working on it. But we're doing a really minimal thing. All we're doing is just clearing the screen, getting the frame rate. Let's run this right now. We have a clear screen and it's about 111 frames per second. Okay, all well and good. Well, what if we change the order that we're using to loop through our color buffer and set the pixels? The most intuitive way is to go, for every X and then for every Y and then set the pixel. And now it's not super dramatic, but our frame rate has dropped from 111 to about 90 or 100. Huh. Okay. Well, what if we reverse that order? And now it pops back up to 110, 111. So what's happening? It seems like the order that we look through the array affects the speed. Yes, actually it does. So let's say we have a really large buffer. You see, I'm trying to fill the whole screen because it becomes more dramatic the more space we're using. If we have a really large buffer and we access elements, there's kind of a cost to a random memory access. But then there's a benefit to a random memory access as well, because we don't just have a single address in memory that we're looking at. The CPU basically grabs the page of memory. The page of memory has that address plus other addresses, a whole bundle. And once it has that cached on its L1 or L2 or wherever it is, cache, then it can access subsequent addresses around that space really, really quickly. So if we run through each horizontal line, then we're addressing pixels which are right next to each other, and that's pretty quick. We can probably cache a lot of that. And then we jump down to the next, to the next scan line. So if we do it this way, then that is cache friendly, that's cache adjacent. If we do it the other way, going through every, drawing a full vertical line and then jumping over by one pixel and then drawing the next full vertical line, well, every time we step down, we are stepping quite a large distance in memory because remember, we have this laid out as horizontal lines. It's one horizontal line on top of the other. So when we step up by one in the Y, we're actually stepping by this many bytes, which can sometimes cause random access, which slows it down. Now I happen to believe that the page size on this CPU is pretty big, which is why it's a more subtle effect, but as you can see, it still makes a difference. The simplest method is simply just to loop through the whole address and not care about X and Y coordinates, because of course we're just drawing the whole buffer. Doesn't matter. We're not drawing lines or anything. Anyway, that was a quickie. I hope you find that interesting. And as a quick kind of addendum to that, right, I don't want to just fill the screen. So I popped on to Lowdev's website, grabbed the Raycaster and just pasted it in, and the library works. We of course need to change that from the STL key codes to scan codes, and also I found in this drawing stuff that STL map RGB it doesn't work. I tried RGBA, none of it works. So I'm just going with the old tried and true bit shift, and yeah, here we have it. Beautiful, yeah, stuff. It's good. It's good. It's fun. don't know why this is white. I don't know if this was meant to be white, but anyway, it works. Yeah. That's fun. That's nice. Anyway, yeah. That's it. See you in the next one. Bye.